I already have my Amazon page on my website open right now, ready to go. All right, e-learners, they're taking a quiz right now, so you're going to see the video of 10 minutes of a screen that says quiz, but then we'll start right after that. No, you're not. Most of the questions are easy. It's just name the angles. You can do this. Don't forget the front and a back, front and a back. Madison. About 3 minutes left. 3 minutes left. All right, make sure your names are on those. Let me have them. Ugly picture. Ugly picture. First side was the easy side, the back side was the more challenging. So if you got the first side, then you should get a C at least. Back side differentiates between the A's and the B's. All right, homework. Questions on the homework? What? Go for it. A test? How many teachers actually put the calendar up every single day to show you what's going to happen? I'm the only one, yet I still have students who say, I thought there was going to be a test. What, there's a test today? It bothers me, right? Why that would happen. Not that I'm complaining. Yeah, I'm complaining. Anyone else? Questions?
18 and 19.
All right, take a look at 18 and 19. Oh, I'm excited. Today's a fun class.
Actually, this is probably the first time I actually
Okay, so I'll just say this. This was that last one that we did, 18, and well, not 19, but 18 was. I just chose to put the numbers a little bit differently. So you have this shape. We don't even know what it is yet. You're told that this is x minus 40, and it's in degrees. So the whole thing is in degrees. And this is x plus 40. And you're told that this is y. And you're told that the opposite sides are parallel of this shape that we already know, but we don't really know. Okay, so if this side, the top is parallel to the bottom, what do you know about this plus this? Was this less your question?
It would equal 180.
It would equal 180. So I could write that. So I could write x minus 40 plus y equals 180. Okay, now tilt your head to the right because we have this one and this one parallel. So what's this one and this one? They also add up to 180 because they're same side interior angles. All right, so we could write x minus 40 plus x plus 40 equals 180. All right, could you solve the second one really quickly because there's nothing but x's? All right, so how many x's are there? And 40 minus 40 is? So we get 2x equals 180, therefore x equals 90. So x equals 90, take that value right there, plug it into that first equation, solve for y. That's how it's done. All right, 19 is done similarly. I can't say that word sometimes. The difference with 19 is that you get some alternate interior angles on 19. Do we have any corresponding angles? No, we have same side interior angles, 2y and x. And then we got those other ones, 3x and 105. So this would be 3x is equal to 105. Divide that by 3, and then plug that in for your x. Okay. Anybody else? All right. I'm going to collect this one. I want to make sure I get to this whole class today, and it's a good one. Oh, it's a good one. What, please?
Is it a good one or is it portraits?
Oh, no, this is a good one.
Good one for you.
No. This is actually a good one. This is, you'll like this.
I don't know. That's for you.
I will tell you when we get to one I'm like, I don't enjoy this class. Not you, but I'm saying the class itself. Like, I don't enjoy it. I think it's really obtuse, pun intended, for today's class.
Yeah. Oh. That was so bad. You broke my brain.
All right. But today's a good one, and it's also the start of triangles. We will literally, and I'm not lying about this, I don't know if there's a single day from now on that we won't talk about a triangle. It's that much. And I'll just go ahead and tell you right now. So triangles, why do we care so much in geometry in plane geometry about triangles? It's because take any shape, including circles, right? Give me a shape, any shape you know of, Chris. Square. You can take a square, cut it in half, and you get two triangles. any shape you can give me, I can break it up into triangles. In fact, I mean, that's literally,
Hex a million gone.
this is how they draw things on your cell phone, right? Like literally. They take the shape and they break it up into little tiny triangles. And that's how they do it. Why triangles? Because triangles are easy. And we got lots of geometry about triangles that we know and understand. You're going to learn this year.
Break a polyhedron.
You can. You just break it all up into triangles. Technically, what they do is they break it up into triangles and other polygons. But triangles are the smallest polygon that we have in terms of number of sides.
Wait, polyhedron.
Polyhedron is 3-dimensional, right? So polyhedron is the twin or the half sister, half brother of polygons. Polygon 2-dimension, polyhedron 3-dimension.
Isn't there an infinite shape of one triangle?
Well, I mean, if you go further in, these are called fractals. The further you go in, you still see the same stuff. So, I mean, there's an infinite number of triangles in a fractal, right? Okay, so we just took our quiz. The test will be on Tuesday, and we'll see if we run into some issues. I'll know, like oh, they didn't get any of that stuff. I better do that again. We'll take. We got plenty of time this year to get through the book. We will teach the entire book this year. And it's such that if we need to take a break, if I got, more than, let's say, 3 people that are lost, then I'm going to take a break and we'll do some reteaching or just some practice work. But for right now, I'm seeing good stuff out of this class. All right, here's your homework. I also don't want you to be confused by, what does it mean good stuff? I'm lost on every single class. Well, yeah, there's going to be some lost, right, in everything that I teach, right? The difference is that after you do your homework and after we correct it or you get your questions answered about the homework, are you still lost? Then you are lost. But this idea of being lost doesn't mean like I tried the homework and I can only do 3 of them. I'm lost. Well, maybe not. Or maybe you need to see how it's done, that sort of thing. Yeah. What is it? It doesn't go through 3 pages? It's just 2 pages? Okay, so 97 through 98.
It's not even 2 pages.
It's just 1? Okay.
That's nice.
You want to know really why it says that? It's because when I change it between honors and regular class, then you guys get not as much homework, so theirs involves 3 pages.
Oh,
I just didn't change it.
They get 3 pages of homework?
Well, select, I don't give them like
It was in the honors.
9th graders right now. There's no 10th graders in honors. The 10th graders are doing algebra 2 right now. That are in honors, which you will take next year. You're not dumb. I'm the math teacher, math degree. I graduated #1 in my university with a math degree. Like no one was smarter than me in math in my university class. I took regular geometry in high school, 10th grade. My butt was sitting where your butt was sitting, and I got a math degree. You're not in a dumb class. You're in a regular class. Well, I will insult your intelligence as the year goes by, but not today.
Think about it. You got the smarty a-holes in the advanced classes and the dumb party.
The Barney animals?
Party animals. Party.
Yeah, I don't buy that either.
I'm not smart. I'm not dumb.
We've got plenty of smart kids in this class.
Smarty pants a-holes in the advanced classes.
I'm not sure what you're saying, but I hope it's not what I think you're saying, all right?
I'm saying a-holes.
Yeah, let's not use that word. That's what I thought you said as well, too. All right. Here we go. Oh, a triangle. We're going to lots of things about triangles this year. I mean, like, lots of things about triangles. Here we go. This is not new vocabulary. You got this in pre-algebra. And I'm not having you write it down. I'm going to review this with you. A polygon is called a closed plane figure. Plane meaning it's on a flat surface. Closed, I'll tell you what that means here in a second. It has at least 3 sides, and the sides are made up of segments, not lines, not rays. They're made up of segments. The segments must be joined at their end points. So graphically, I'll show you what this means. So it says a polygon has to have at least 3 sides. Okay, 1, 2, 3. There's 3 segments, and it says they're made up of segments, but the segments must be joined at their end points. So if I put the black one right there, and I put the blue one right there, but I do not join the end points, I put the red one somewhere there, I made a shape, but I didn't make a polygon. That is a shape made up of segments, but the red one didn't join to the end points. If we do connect those 3 ones, right, there's the black one, there's the blue one, there's the red one, but we join it at the endpoints, we get a shape that you guys already know. This is called a
Triangle.
so that's our first polygon. Write this down, box 1. Now, should we put this in our book of truth, or do we put it in our notes right here? I'm saying I think you guys know what a triangle is. It doesn't need to go in your book. I could be wrong,
I do.
right?
I don't have it.
Okay. You will have a sheet here soon.
No. Think mine.
No. So if you choose to put it in your book of truth, if you choose to put it in your book of truth, that's fine, but you don't have to. So a triangle is a 3-sided polygon. 3-sided polygon. Now, Bailey, what do you remember? How do we name triangles? Like, oh, it's the blue one. No. What's the name of this triangle? Karis, you remember? Say again. BAC, is she right? She is right. How do we name any polygon? Bailey, pick a letter, any letter. And you go either clockwise or counterclockwise. Give me all the letters. There it is. Now go the other direction. BA what? CAB. So there's lots of different ways of naming polygons, but you must follow the pattern. The pattern is you pick a letter, and you either go clockwise, you got to give me all the letters, or counterclockwise. We also have a symbol for triangle. Bailey, take a guess. It's a triangle. The corners of a polygon are called vertices, plural. One is called a vertex. All of this in box 1, please. If you need to put this in your book of truth, you can. I'm only showing you one of multiple ways of naming the blue triangle right here. Triangle symbol ABC. Pretty simple. We don't have an additional way of saying the measure of the triangle or anything like that. We will measure the perimeter. We will measure the area, not today. What's your question, Michael?
What's the difference between a corollary and a postulate?
I'm going to get to that here in a second. There's a big difference between those two. Okay, so we will have symbols for parallelogram. We'll have a symbol for rectangle. We don't usually put a symbol for hexagon and larger than that, but we will see parallelogram symbol. I don't think we ever use the square or the rectangle symbol. We good? Review? Yes? No? Right. Okay. All right. So this is also review. Box 2. If it needs to go in your book of truth, we're going to use this the entire year. But my belief is you can already tell me. Connor, if I were to give you a triangle and I were to measure the sides, and you were to look at those measurements, we can name 3 different types of triangles. Do you remember from pre-algebra any one of those 3 names? And this is by sides, not by angles. Okay, do you remember any of them? By side lengths. We classify triangles by their measurements of their sides, not their angles, but their sides. You remember the names? Okay. Chris, you remember? How do we name triangles by their side lengths? There's 3 of them. All right, so I guess you need to write this down, right? People that have their hands up there, I'm pretty sure you probably know. Plus, you got your book open.
No, actually, no.
All right, what are they?
I only one of them is scaling.
Scaling, it's the one that no one remembers. Scaling is the one that has no equal sides. You better write this down since none of you, no, that's by angle measurements. This is by side lengths. We will be using this the entire year. Yes, you did learn this, all of you. Yes, apparently you need to be prodded into remembering this. A scaling triangle has no sides at the same measurement. Liam, you remember the other ones now? What's an equilateral? So if all the 3 sides have exactly the same measurement, we call it an equilateral. And the one that has 2 equal sides is called a, somebody? Anybody? There you go. There's all 3. Notice the red tick marks. Tick marks aren't always red. They could be black. But most of the time, they'll put the tick marks as red. These are the ones that I guarantee everyone's had this, but clearly not many of you. Maybe Liam's the only one that remembered them, although he was too afraid to give me the answers.
No, I didn't know what you're talking
about. Okay. I can't think of anyone that has not been exposed to this before.
Me. I was homeschooled.
Me too.
Really?
I was homeschooled and I was exposed. to
You've
this.
never seen this.
I thought that
I
was
did on the
reality.
beach.
Okay. Well, then that might explain it right there. So Bailey, you are writing this down because we'll be using this, and the book will use these words all the time. Hey, you got a scalene triangle. Hey, you got an equilateral triangle. Hey, you got an isosceles triangle. We will get lots of isosceles triangles. Not so many scalene, but and not too many. More equilateral than scalene. But lots of isosceles. All right, does everybody have this written down? It's also in your book. So that's how you classify triangles by their side lengths. All right. We can also classify triangles by their angle measurements. These are the more memorable ones, right? This is going to be box 3. So give them to me. Right, acute, and obtuse. Okay. So an acute triangle has, this is important, this might need to go in your book of truth. Acute triangle has 3 acute angles, 3 of them. Well, the next one is a right, I'm sorry, it should be a right, but they went obtuse. I'm just doing it from what's in the book. The obtuse has only 1 obtuse. Well, if it has 1 obtuse angle, guess what else it has? It has 2 acute. It doesn't say that, it should. 1 obtuse, 2 acute. Why can't it have a right angle if one of the angles is obtuse? That makes it a right triangle, so that must be the other one. That's not the real reason, but I'll go with that for right now. A right triangle has 1 right angle, and can it have an obtuse angle? Do you know why? I like that. That's absolutely true, but we'll prove why that's true here in a second. So we have classifications by side measurements and by angle measurements. These are absolutely like the first, I don't know, gimme questions on a test. Hey, classify the triangle by its angles and by its sides. If you miss this, shame on you. This is like give me points, right? You should be able to do this. So if it needs to go in your book of truth, put it in there. If it's like, oh, I already knew this, then you're not going to forget that. Yeah.
Were we supposed to like do theorems 9 and 10 from yesterday?
We were. There's one that I left off, and that is what happens if the angles are all the same? If all the angles are the same, we call it we call one with all the sides an equilateral. Lateral means side. We're going to call it a equiangular. That one is very memorable. You won't forget that one, but it's called equiangular.
I didn't get that.
Well, not always, but sometimes you might take a pre-algebra course where they don't talk about this one. They'll talk about those 3, but not this one. Okay. Equiangular just means all the angles are the same. All right, so we got 3 by side measurements, 4 by angle measurements. Okay? All right. You don't need to put this anywhere. In geometry, you're allowed to draw little pretty things on your paper, right? We call them auxiliary pieces. An auxiliary thing is something that isn't originally drawn on the diagram. So if I want to add a line to my picture, I can. I mean, I can draw a line. I got a straight edge. I got a pencil. I can draw a line. We call them auxiliary, whatever it is you're drawing. Auxiliary ray, auxiliary line, auxiliary flower, right? Whatever it is, auxiliary heart, right? We call it auxiliary line. I'm about to use this, by the way. All right. So here we go. Hey, remember when your teacher said that the interior angles of a triangle add up to 180? Remember that? Like, hey, they all add up to 180? Did you believe them? Why did you believe them? Because they're the math teacher and they said so, right? Is that good enough for geometry? Heck no, I got to prove it, or you got to prove it, right? That's what we're about to do. We're about to show that if you add up the interior angles, you get 180. All right, that's our first proof. And you can do this one, by the way, with one hint from me. All right, grab the pencils. Let's go. It's on your sheet. It's next to your foot. All right, here we go. This looks like an impossible proof, and it is until you get my hint. All right, so it says, I'm going to try to prove that 1 plus 2 plus 3 is 180. Well, we got a given. Hey, guess what our given says? Basically nothing. There's just a triangle. Doesn't tell us anything is congruent, anything's equal, anything adds up to 180. It just says, you got a triangle, baby. All right? Nothing good there. That's the given. I need to show that right there. It seems like an impossible task because I can't tell anything. And by the way, I can't tell that one's acute or obtuse from the picture. Right? You're not allowed to do that. Right? If it's not indicated, it doesn't say that 2 is obtuse. It looks obtuse. Looks right, maybe. I don't know. You don't get to say that. So this is where, this is a pretty slick trick. They introduce a flower, a heart to your picture, except they don't choose a flower or heart. They choose a line. So we're going to make an auxiliary line. We're allowed to do this. I'm just going to draw a line. I'm going to put it in a very specific part. I'm going to draw a line. There's nothing special about B. I'm just choosing B. I'm going to draw a line that goes through B. You with me? That's parallel to AC. I'm going to draw a line through B that's parallel to AC. Now, if you draw a line, how many points do we need? We need 2. So I'm going to add another point as well, too. So there's my line. And I make it, typically auxiliary lines are dashed. They're trying to indicate that it's not part of the original picture.
How is that parallel?
I'm claiming it is. I'm going to claim it's parallel. Don't, if it certainly looks like it's parallel to me, but if it doesn't, if it looks slightly off, then it's still parallel because I said so, right? How do you do that in a proof? You say construct it. And construction means, well, you take your straight edge, you make it parallel to AC, and you draw it.
Oh, AC, sorry.
Okay, are we better now?
Yeah.
All right. Did I say it wrong?
No.
Okay.
No, I was thinking AB.
So we good with my construction? I made a line that goes through B that's parallel to AC. So how many parallel, this is the hint. Oh, by the way, the reason is you're allowed to construct things. You want to put a dot right there, you can. Hey, put a dot right here. Hey, look, I made 2 more angles. I'm going to give them names. What do you want to name them?
Bob.
Okay, Bob and Fred, except we name points or angles with either numbers or letters. I'm going to choose numbers. So I'm going to name this one. I'm going to name this one 4 and 5. This is called labeling. Label angle 4 and 5. You're like, well, how did you know it's 4 or 5? I made that number up, and you can do that. That's called labeling. Yeah.
Okay, so are we able to just construct whatever we want?
Anything you want.
Because infinite planes, infinite lines.
Because you know how to draw lines and rays and segments and points. Yeah. Right? We can do that. And you can also, now, you can say that things are parallel or perpendicular, any of that.
An angle bisecting.
We could, and we will this year, just not on this one.
Okay.
All right, everybody with me? Why did I just make something parallel? What have we been doing for the last 2 days? What have we been doing for the last 2 days? We have been making lines parallel and a transversal. Does this picture look like this? Not without a little bit of an imagination, right? However, if I were to erase this line right here, does it now look like this? The answer is yes. So you just imagine that this was not here. Now it looks like this. Hey, check it out. What can you tell me about angle 4 and angle 1? See my 2 dots? What can you tell me about angle 4 and angle 1? Therefore, they must be congruent. Okay, now imagine that's there. Imagine that AB is no longer there. What can you tell me about 5 and 3? They're also congruent. That's why you made this auxiliary line. Now we can say something about the triangle. Oh, you can also say something about 4, 2, and 5. What can you say about 4, 2, and 5? Why? They make up a line. You know everything you need to prove this now. So let's write this down. So it's not in any specific order, but 4 plus 2 plus 5 equals 180. Why? They make a line. You could also say, postulate 4. We okay? What was the other thing we said about this construction? We said 1 and 4 and 3 and 5. We said those were, notice there's a comma right there. 4 is congruent to 1, alternate interior, comma 5. We're not saying 4 and 1 and 5 and 3 are all the same. We're not saying that. It could be. We're just saying that 1 is congruent to 4 and 3 is congruent to 5. Why? Because they're alternate interior angles. If things are congruent and they're talking about angles, what do you know about their measurements? So my next statement is this statement with m's next to it. Their measurements are the same. 4 is the same as 1, 3 is the same as 5. I'm not saying they're all the same number. It could be. And then not substitution, but we're going to do some subtraction. If 1 is the same as 4, then in this statement, right, where are we at? If 1 is the same as 4, and this says 1 plus 2 plus 3 equals 180, but 1 is the same, oh, you're right, I'm sorry. I'm going to do a substitution. Instead of 4, I'm going to write 1. Instead of 5, I'm going to write 3. And I got my last statement. We're done. I'm thinking about the next proof. Uh-oh, I already gave it away. There's some subtraction involved. Hey, this is why your pre-algebra teacher didn't say, well, let me prove it to you. Well, this is how you prove it. You need to know about alternate interior angles and parallel lines, and that's why they just say, trust me, the angles add up to 180. All right, this is the first big one. Big one. The 3 interior angles add up to 180. We will use this the entire year, lots of times. Lots of times. This is QED, Theorem 311. The sum of the interior angles of any triangle add up to 180, as long as it's in plane geometry. So theorem, it says the sum of the interior angles is 180 degrees. So 1 plus 2 plus 3 equals 180. And by 1 plus 2 plus 3, I mean the measure of angle 1 plus the measure of angle, so on and so on. This one's big. And oh, by the way, this is still pre-algebra. We even haven't got to high school geometry. We're about to move to high school geometry. But your pre-algebra teacher never proved this to you. They just said, trust me, it's 180. Not that they were lying to you, but because it would have been too hard for them to prove it to you. They could have proved it for a one triangle, but they couldn't have proved it for all triangles. We just proved it for all triangles. We never claimed that it was a right triangle or equal angular or isosceles or acute. We just said it's a triangle. We good? And so that one's absolutely in your book of truth. All right. So Micah's question is that today we get these things called corollaries. It would have been okay if we continued to call these theorems, right? A corollary is a theorem. But corollaries come specifically from a theorem. If you think about a tree and leaves, the tree is the theorem, corollaries are the leaves on the trees. They're attached directly to the tree, right? You got trees in the forest, those are all your theorems, right? But the leaves are attached specifically to a tree. So we're going to do corollaries, and these are not named very well. In fact, all corollaries are named corollary 1, corollary 2, corollary 3. Go figure. So if you say by corollary 1, I'm going to say, well, which corollary, right? So most of the time we don't say by corollary, we say by, we give the name of the corollary itself. I understand that corollaries are confusing for some students at start, but they're just basically theorems. So corollaries they can be easily proved. We're going to prove them like in two sentences or so, and you will not have these for homework. I'm going to give you, I think, 4 corollaries right now, and they come directly from the previous theorem that the sum of the interior angles add up to 180. So all of these are because of that. All right, so here's my first proof. A first proof, and it's going to be a corollary. It says this, look up here. It says if these two angles are congruent to these two angles, then the third ones must be congruent to each other. And that's what we're about to prove. So if these two angles are congruent to these two angles, the other third pair, they must be congruent to each other. Okay? This one's pretty quickly done. Pretty quickly done. Okay. What was the theorem? What did the theorem say? What the one you just wrote down? What did it say? Okay, so what did you say about triangle ABC then? Tell me what's right.
Angle 1 plus angle 2 plus angle 3 equals 180.
And we would just say the measure of angle 1, and then we could say the same thing for this angle, right? Or this triangle as well too. So because of theorem, whatever it was, right? We can say those statements right there, and that's theorem 3. Was it 11? 11.
You already forgot it?
I know, because I'm not going to remember it. I'm just going to say the sum of the interior angles of triangles 180. I'm not even going to try to remember the numbers. That's just way too confusing. Okay. Madison, what's the trick that we use all the time in proofs when you see a statement like this? When you see a statement that looks like this, what's the trick we use every single time? If this one equals 180, this one equals 180, what do? Set them equal to each other, right? They both equal 180, so let's set them equal to each other. Bailey, you're kind of just sitting there, right? There's a difference between sitting there and I'm getting everything you're saying, and it makes a whole lot of sense. If that's what's going on, that's a good thing. But if it's just a sitting there and we're not doing anything, man, this stuff will build up really quickly. Okay, so all Madison did was simply say if they both equal 180, well, then they must equal each other. That's substitution. Seth, what are we doing next?
Subtraction.
Yeah, and we're going to do some subtraction, but this is where geometry gets really pedantic. Is that before we do subtraction, it never said that these are equal to each other, it said they're congruent. So we got to add one silly statement that says the measure of angle 1 equals the measure of angle 4, the measure of angle 2 equals the measure of angle 5.
You mark us off.
I would not like say your proof is wrong, but I would simply add, oh, minus a half or something. Hey, you forgot to say that the measures are equal before you did subtraction. Because you can't subtract a congruence from an equality statement. They're, apples and oranges technically. Now can we do subtraction?
Yes, sir.
We can. If 1 is equal to 4, I got a 1 and a 4 here. If I subtracted the same thing for both sides, the 1 and 4 poof go away. If 2 is equal to 5, I got a 2 and a 5 on both sides of the equation. I could subtract those, and then I would be left with measure of angle 3 equals the measure of angle 6. Do you see what I did there? Because we said that 1 is equal to 4, there's a 1 here, there's a 4 here. Subtract them from both sides of the equation. So that was subtraction, and then therefore, what's the last statement? Definition of congruence. If the measurements are equal, that means they're congruent. Hey, so all we proved is that if 2 angles of one triangle are congruent to 2 angles of another, what can you say about the last angles? They must be congruent. This is corollary 1 to theorem 3, whatever, 11. All corollaries are going to be named corollary 1, corollary 2, or corollary 3, or corollary 4. So this is corollary 1 to theorem 3:11. How would I remember this one? I'm not going to remember it's corollary 1 to 3:11. I just know that if two angles of one triangle are congruent to 2 angles of another one, the third ones are congruent. Here's your if then, if you like to write it in more concise ways. If you do this, then you got to draw the picture. Will I use this one? Yeah, occasionally. Not very often, but occasionally. That's corollary 1. Ooh, I don't know if I'm going to make it through today's class. We have to have this full class. We can't do homework without the full class. And I don't want you to try it on your own.
I'm literally doing it right
Well, okay.
I don't like drawing.
I'm literally offering not to give you homework tonight, and Matt's saying, you can do your homework. Okay. Well, you're also able to look at the theorems and kind of figure this out. You got to go through all the theorems, though. All right, we good? All right. And in this case, corollaries. All right, corollary 2 to theorem 3:11 says this. If it's an equal angular triangle, guess what each angle is? If it's an equal angular triangle, guess what each angle is? Therefore, it must be. Okay, true, but therefore the angle measurement must be. Prove it. Why? You can do it in like one step. Why does that mean that the angle has to be 60 degrees?
Because they all add up to it, right?
Yeah, add up to what?
180.
And you have 3 of them and they're all the same, therefore,
Right, all up.
why?
Because they add up to 180 and that's the
Okay, keep
Oh,
talking.
straight line.
Well, I'm thinking, why is it 60 and not 70?
Because that it goes 21 down.
Okay, he's doing addition, I'm thinking division, right? Were you thinking division or multiplication? Or were you thinking addition? Okay, fine, that'll work. You proved it. I'll buy it. Hey, the only 3 numbers that are the same that have to 180 is 60. There, you proved it. That's corollary 2, that equilateral, equal angular triangle, all the angles are 60. By the way, it's also true for equilateral. All the angles are 60 degrees. An equal angular is an equilateral triangle. Didn't prove that, but we can prove it pretty simple. We actually have to get a few more theorems under our belt before we prove that equilateral is equal angular. That's corollary 2. How many corollaries we got, Micah? 4? 3.
Sorry, no.
It's 4.
Yeah, 4.
All right, moving on. Corollary 3 says this. What kind of triangle?
Right.
If you have a right triangle, what can you tell me about these 2 angles? They're what? That's the next one. That's corollary 4. They're what?
Acute.
Why are they acute? Prove it. And you're right, by the way. Same way Wes proved it. What? And if one of them is 90, how much is left? If one of the angles is 90, how many degrees are left? Well, then how big is this one? Even if it's 1 degree, that means the other one can't be 90. It's got to be 89, right? Hey, no homework tonight. We got to finish this tomorrow. So we'll finish this tomorrow.
Let's go.
I literally just did.
Well, then guess what that means tomorrow? Then you will have no homework tomorrow if you want to finish it.
That means I don't just
All right, e-learners, the quiz is posted. That means that you need to take the quiz. Even though it has the homework posted for tonight, eventually, I'm going to put it off until the day after tomorrow when it's actually due. So give you an extra night. We'll finish tomorrow's class. We'll finish this lesson, and then it'll be the same homework. So if you want to get a head start on the homework, you can. Some of the students are saying they can figure it out themselves, and that's cool. If you have any questions on any of that, if that didn't make sense, send me an email. Catch you later.